Number 1. So the drag force acting on an object falling through air is given by this expression, where A is the cross-sectional area, V is the velocity, rho is the density, and C is the constant called the drag coefficient. So drag coefficient is C. Use SI base units to show that the drag coefficient has no unit. So we need to show that the drag coefficient has no unit. So first of all, we need to make drag coefficient becomes a subjective formula. So drag coefficient is equal to 2FD by rho A V square. So force is a unit of force. So FD is the force. So force is equal to mass into acceleration, and the unit of mass is kilogram, and for acceleration it is meter per second square. So kilogram meter per second square. And for density, density is equal to mass by volume. So mass has a unit of kilogram and volume has a unit of meter cube. And since it is divided, so negative meter cube. So kg and kg cancels. Then so meter per second square at the top divided by meter to the power negative 3, meter to the power negative 3, and since the base is same, so we need to add the power. So minus 3 plus 2 and minus second to the power negative 2. So second to the power negative 2 cancels each other out. Then meter divided by minus 3 plus 2, that is meter. So it cancels and the overall unit becomes 0. So it is shown that the drag coefficient has no unit. Part B, figure 1.1 shows a sphere falling at a terminal velocity in air. So the sphere is falling at a terminal velocity in air, and since it is falling at a terminal velocity, so terminal velocity is a constant velocity, and since velocity is constant, so velocity is constant or velocity is same. Since velocity is same, so we know that acceleration is equal to change in velocity by change in time, and here it is terminal velocity. So terminal velocity means that the velocity is same. So the velocity is same, therefore the velocity is not changing. So since the velocity is same, so it is not changing, therefore the change in velocity is 0 divided by time. So we can see that the acceleration becomes 0, and since acceleration is 0, so resultant force, that is F net, is equal to mass into acceleration, and since acceleration is 0, so the resultant force is 0. So as the object is falling at a terminal velocity, that means the resultant force is 0. That means force downwards must equal to the force that is upward. So assume that the upthrust on the sphere is negligible, so there is no upthrust. On figure 1.1, draw and label arrow to show the direction of the two forces acting on the sphere. So we need to show the direction of the two forces. So first of all, the weight is acting vertically downward from the center. Since it is an uniform object, so the weight is acting vertically downward from the center. And drag force. So drag force is a resistive force that resists the motion. So drag force is a resistive force, that is the drag force acting on the object falling through air. Since the object is falling downward, so the drag force must act upward. Since it is the resistive force, so the drag force is acting upward, and this arrow must have the same length as the weight. That is, drag force have the same length as the weight. Then the mass of the sphere is 49 gram. Calculate the drag force acting on the sphere. So drag force. So we have found that the terminal velocity, the velocity is same. Since velocity is same, so acceleration is 0. Since acceleration is 0, so the resultant force is 0. So downward force is equal to upward force. So the downward force is equal to the upward force. So it cancels and the resultant force becomes 0. So the downward force, that is weight, is equal to the upward force Fd. So weight is equal to Fd. So we have given the mass. So we need to find the value of drag force. So we have given the value of mass, and we need to find drag force. So by using weight is equal to mass into gravitational field strength. So 79 gram. So 49 gram. So we must convert 49 to kilogram. That is 49 by 1000 kilogram into 9.81. That is the gravitational field strength. And you have to remember that the gravitational field strength for physics is 9.81, and for mechanics it is 10 meter per second square. So by using the equation we calculate the value of weight. Since we know the value of weight, so weight is equal to drag force. So weight is equal to drag force. So weight is equal to drag force, therefore the drag force is 0.48 Newton. then the sphere is falling in air at a terminal velocity of 25 in SI base units. So terminal velocity of 25, and since it is velocity, so it has a SI unit of meter per second. That is, the sphere is falling at 25 meter per second. The density of the air is 1.2 in SI base unit. So density is mass per kilogram. So mass has a unit of kg and kilogram has a unit of meter cube. So divided by, so it is divided, so meter to the power negative 3. So density, we know the value of, so first of all, we know the value of velocity, density, and the diameter. So this is the diameter. Now calculate the drag coefficient C. So we need to find the value of C. So initially we make the C becomes a subjective formula from this formula. So by using this equation, we need to substitute the value of the velocity. So we have given the value of velocity, then the value of density, and the diameter. So by using the diameter, first of all, we need to find the value of area. So since it is a sphere, so it is a circular object. So for circular object, area is pi r square. So pi r square, or for diameter it is pi d square by 4. So pi r square or pi d square by 4. So we know the value of diameter. So pi d square by 4. So we know the value of velocity, that is 25. We found the area, and we know the value of density. And what is the value of force? Fd. There is a drag force. Drag force is 0.48 Newton. So 0.48 Newton. After substituting the values, we calculate the value of C as 0.4527. There is approximately 0.45 to two significant figures, and it has no unit. C has no unit because here we have found that C, or drag coefficient, has no unit. Therefore, we have given our answer as 0.45.